Hey everyone, welcome to the Fargo 3D Printing Show. Not sure what podcast number it is, but today we have a special guest. We have Dan Sawyer from NatureWorks on the podcast today. So he's going to talk a little bit about what, PLA and Ingeo, and then we're going to kind of talk about 3D a little bit, and then kind of go from there. So welcome to the podcast, Dan.
Thanks, Jake.
So what's your title at NatureWorks?
At NatureWorks, I'm the global leader for our new business segment. And in the new business segment, we work with things like printing and graphic applications. So 3D printing falls within that. I also do some work on building and construction applications, and then also non-food packaging applications. So a big part of our business at NatureWorks is around packaging applications, and then we have quite a bit in fiber applications using our plastic. And I'm working on pretty much everything else that doesn't fit into those nice categories that we have for our core business. So kind of a business incubator for the company, looking to develop new uses for the plastic.
Okay. So how did NatureWorks get started? Because I know it was it like the 90s or something where it kind of like was formed, or kind of give us a history of PLA and NatureWorks.
Yeah, and in my history with the company almost goes back almost as far as NatureWorks. It started out as a project within one of our parent companies, Cargill in Minnesota, and trying to find new uses for some of the raw materials that they handle. And so they looked at this as an outlet for one of their products, which is their corn milling process. And we've really taken it a lot further. So I started back with the company in the mid-90s, in 1995. And at that point in time, we were manufacturing the plastic in Minnesota at kind of a semi-commercial scale. And we've, since 2001 timeframe, been manufacturing in Nebraska at commercial scale. So now we have about 300 million pounds of capacity for the plastic. And so
a little bit of PLA.
Yeah. As you can imagine, packaging and fiber applications weren't enough. We want to be in more things with the plastic and find effectively ways to take greenhouse gases and convert them into useful products. Kind of a noble concept, and that's really the way we've been looking at it more and more. Today, we use an agricultural resource, but we're doing research to look at how could you even convert greenhouse gases like methane directly into the feedstock for our polymer in the long run. So that's today we use corn in Nebraska. We wouldn't need corn, but we use it because it's the lowest cost feedstock where we manufacture today. But we look at other resources, other sugar resources, or directly converting the greenhouse gases themselves.
We have sugar beets here.
Yeah, sugar beets are actually a resource that's used to make lactic acid. The true starting material that we use for the polymerization is lactic acid. And some of the manufacturers in Europe use beet sugar as the raw material. Absolutely.
Is sugar beets big over in Europe? I guess I'm not really sure.
Yeah, in parts of Europe they certainly are. Yeah, and so for our process, it's really indifferent to the type of sugar. The core is really a fermentation process, whether that is a fermentation that comes from a sugar or ultimately a cellulosic material, maybe as a second generation, or the next step that we're looking at, where a fermentation process could take greenhouse gases like methane directly and convert those to lactic acid.
We need to do a plant out in western North Dakota.
Yeah, with all the burn. Maybe an option. We look at biogas as a byproduct in anaerobic digestion. Could be another resource. So a biofermenter could be another resource in the long run. So for us, it's really about manufacturing the material at large scale and with high quality that comes with a real true commercial process for making it.
Interesting. So PLA, I mean, in 3D printing, how did you guys kind of get involved with using PLA in 3D printing, or how did that market approach you? Did you how did that whole relationship work?
Very good question. Yeah, I was approached as kind of the dumping point for anything new that comes into the company. When I established this new business segment a couple of years ago, everybody sent everything my way, and 3D printing came to me for sure, and didn't recognize maybe the potential of it, and certainly our company even less so. One of my colleagues said, wait a minute, let's look at this, because injection molding is already in a marketplace for us, maybe we should be more considerate of people that are doing some prototyping with 3D printing as a means. If they're prototyping with our material, it increases the probability that ultimately someone could injection mold with our material. What we failed to appreciate really was how well our material would work in that process, and it isn't exactly the same as injection molding. And so as kind of the desktop community evolved, people that are doing not necessarily prototyping, but making their own parts at home or in an office or a business, we didn't appreciate how much that would evolve so quickly. And so, we've gotten more and more engaged and tried to get involved in it. And now starting to look at, how could we make our material even more suitable, or how could we leverage what we've learned in some of our other application areas, durable injection molded goods, for instance, where we've formulated our material to give it certain properties, maybe improved heat or improved impact, and, looking at how we could bring that back into the 3D market in the long run.
So when was the first time you actually saw 3D printing cross your desk, as far as, because you said you're kind of the funnel for a bunch of new stuff. When was the first time you really heard of the 3D printing side of things for your product?
Probably a toss-up. I think as part of the Society of Plastics Engineers, we were involved in that organization, the SPE, and we did a tour at Stratasys as part of a local SPE event. And so saw some of the ABS stuff. Yeah, we're in Minnetonka as our headquarters, and just 15 minutes down the road from where Stratasys is headquartered. And so they toured all the local plastics folks and saw what they did. They printed an extruder element and had it as a giveaway. And so it kind of got that prototyping mindset going. And I don't remember exactly when that was, but it was, 4 years ago or so. And we kind of started to ask, well, could our material be used in this field? And it's kind of gone from there.
Yeah, it's really, really kind of blown up, because, PLA is really great to work with. But I want to take a step back, to what your material is actually used for besides 3D printing. Because, you said that this is kind of developed in the last couple of years. What's kind of the main thing PLA is used for? Because I know the 3D printing community sees it as, this is what PLA is always used for, But, what was it before, or what is it still?
Good question. For us, our business is much more than just 3D, for sure. That's a growing hot market for us. But before that, we were used in a lot of packaging applications. I think some of the initial gravity was towards applications where people viewed it as biodegradable, not even knowing what biodegradable really meant to them. And people, when you describe a polymer that's made from plant-based resources like we do, or renewable raw materials or greenhouse gases, people instantly will just say, so it's biodegradable, and not realize what that means. And for us, it really is a compostable resin. And where that adds value is in some of our food serviceware applications, where we can take the material, people use it as a food service article, a plate or a bowl or a cup, and sometimes it gets contaminated with the food that they're using it for. If a venue can take that food waste and the packaging or the food serviceware to a composter and not have to pay a tipping fee to put it in a landfill, to them that's a win. And so that's really where that compostability adds value. So that segment of our business really relies on that. A lot of our other business segments really rely on the inherent properties of the material. Some of our fiber applications, where the fibers made from our material actually wick moisture better, so they can be comfortable in hygiene applications. And we have a number of different application areas in fibers where the unique performance of the material really differentiates it, and people like to use it in those areas. We have quite a bit of work going on in rigid packaging, and that's a little different from food serviceware, even though it also oftentimes contains food, in that the food is oftentimes pre-packaged in the plastic. It would be thermoformed as a form-fill seal yogurt tray, like six-pack of yogurt containers, where all in one process. The sheet is heated up, formed into the yogurt cups. The yogurt is filled and then it's sealed all in one go. And what one of the big yogurt companies has found is our material is stiff, and they're able to down gauge and actually save some money, have a tougher product, and be using a renewable raw material, so lessen the carbon footprint of their packaging, all in one material change. Also addresses some of the concerns that people have around healthier plastics. So not that we're claiming to be a healthier plastic, but people are concerned about styrenics. People are concerned about things like bisphenol A, and we don't use those in our manufacturing process. So it gets away from some of those concerns that people have.
So you mentioned a little bit, people sometimes think, okay, it's made from plant material, biodegradable, and then compostable. I mean, what's really the difference between biodegradable and compostable? Because it doesn't sound like they're the same.
Yeah, absolutely. Different words. Biodegradable really doesn't have a definition other than it returns to nature and is relatively harmless. There's not really a test for biodegradability per se. There are different tests depending on the different environments where something will be disposed of. So if an article is going to go into a compost stream as where it will be disposed of, there's a certain test that you have to meet to show that a product's compostable. Generally speaking, composters don't want any plastic in their stream. Their business model is to sell good, useful compost. Mm-hmm. They want degradable organic materials, grass clippings. They want food waste that they know can produce good compost. So any plastic, they kind of view it as a potential contaminant. Where they're willing to accept it is if they have a product that's clearly labeled that they know is compostable and brings them that food waste that they really want. In this market, in 3D printing, we really don't see the composters wanting any 3D printed parts. We think recycling will be a better end use for the material.
Taking that back and grinding up and making more filament.
Grinding up and making more product of some sort, whether it's the filament or the spools that the filament comes on or something.
So what sort of recycling program is there? I mean, if someone has something that's made out of PLA and they want to recycle it, how would they go about doing that?
Yeah, we already do some work with some of the larger manufacturers to take some of their post-industrial material and connect them to users who are using that post-industrial scrap.
Okay.
With individual users, it's a little more challenging, but where we can, we're working with some big brands that would try to use that. We're trying to find outlets, and people are trying to develop applications based on recycled PLA. We have a couple of companies we've been working with that are developing specific recycled PLA-based formulations for things like injection molded articles. The spools for 3D printing might be an obvious one where we could see it going into.
Sure.
Yeah, because that's what we have our filament here. Then our spools are actually made from PLA. So really, really neat stuff, I think. But so Ingeo, so we're one of the few filament manufacturers to use Ingeo as a branding. So from NatureWorks side, what does the Ingeo branding really mean? Like what's
for us, the brand was really meant to help differentiate PLA in general. When we talk about our carbon footprint with our material, that's specific to the process that we use in our commercial manufacturing facility. So we've gone out and done the life cycle work to qualify our net greenhouse gas equivalents, non-renewable energy use, and several other life cycle indicators about our plastic so that you can benchmark it against a competitive plastic like ABS or polystyrene in some of our packaging applications that's specific to our manufacturing process. Other producers of PLA that are out there, there are some in Asia, there are some in Europe. When you see Ingeo, that's not their product, that's not our process. When you see Ingeo, it's NatureWorks' process for making PLA, and thus it comes with that environmental footprint that we've calculated. It also is meant to show that In the filament world, where we license our brand name to a limited number of users, those are companies that we've gone and we've evaluated their filament, we've run it, we know that they're doing things in a responsible way. So whenever we license our trademark to be used with products, it comes with an agreement to use safe materials as components and to use good labor practices, a number of different criteria that we tag along with the brand to make sure that people are acting responsibly when they use it and producing good quality material that people may use filament, and if it's a low quality filament in this market, regardless of what it's made from, they'll conclude that, hey, this product doesn't work. We don't want that to happen. And so if people are using one of the filaments that companies that are using our trademark, those are companies that we know the filament's going to work. And so we don't want people to conclude that PLA doesn't work just because someone's making a poor quality filament.
Sure. Well, it's kind of like whatever, some of the stuff that we get from that we've seen in the market as far as the filament brands go, some of them just don't work at all. They either have insufficient print temperatures where one part it'll be really stiff.
There'll be different grades of PLA,
wild inconsistencies through.
Yeah, I got one ABS from overseas somewhere, some cheap $20, $30 stuff that I just needed to have on hand. Mm-hmm. And granted, it was ABS, but I put it in some delimonene, and the good stuff just it works. It would actually stay up in the delimonene. The hips would go away. Mm-hmm. Where this Chinese or Asian one, the whole thing dissolved within a day or two, and so you don't know what they're mixing in.
Haven't we actually had some that's sitting on the spool, and as it's been sitting on the spool, it starts to break and fall apart right on the spools?
Yeah.
Yeah. So when we license our trademark to brands, we've done some homework to make sure that the quality is there. So you're going to get a product that people aren't going to conclude that PLA doesn't work. Mm-hmm. Because the filament quality is poor. It's good quality filament.
Mm-hmm. Besides 3D printing, what's the coolest thing you've seen PLA used for? Because 3D printing is obviously the coolest thing, but
what's the second?
What's the second coolest thing that you can say?
Okay, I'm gonna take some time, but the one that I would still rank number one. There's a group out of the University of Illinois that is taking our material. They're weaving a fabric, and oftentimes is co-woven with a fiberglass, impregnating that in a thermoset, and they're catalyzing the PLA to depolymerize to the monomer, the lactide that we use to make it, and then under vacuum they're extracting that out, and it leaves behind a vascular network that could be used to pump fluids through. It could be used as a reactor system. It could be used in aerospace applications as a cooling medium or a temperature sensing medium. That was one of the coolest ones. I pretty much giggled out loud when I read some of the patents on that one.
Yeah, that one's up there.
Now,
that I have to say.
The second one I would have to say I learned of today. There's a group here in North Dakota that's doing soil degradable formulations. Not purely based on PLA. They have some other materials that are actually soil degradable. Ours would be compostable, that are in soil sensors that go away over time. And that one really pretty much floored me. Microelectronics printed on degradable polymer matrix that will go away in the soil so that you can sense it over a period of time, but it doesn't leave a residual in the soil.
See, you found something awesome when you come up here.
Plenty of innovation here in Fargo.
Yeah. I mean, it's just the people here and the students at the different colleges. I mean, you go to like the Innovation Challenge. I don't know if you've heard about that at NDSU.
Yeah, roughly heard about it. Yeah,
but some of the
details.
Yeah, some of the stuff that these students are coming up with are just, and this project, the project you reference isn't from students, but some of the stuff that's in this town is pretty remarkable.
There's a lot of research going on that kind of is under the radar just because it's small, but it's very interesting nonetheless.
Yeah.
It's Fargo. Nobody really knows what goes on.
Nobody knows we're here.
All we know is we drink a lot and we got a lot of restaurants. So
pretty good at using renewable raw
cool.
materials.
Yeah.
Plenty of them grown here during the warmer months.
Yeah.
Oh, we just need to figure out what to do with all that snow.
Yeah. If we can figure that out,
It'd
we'll be set.
one heck of a renewable raw material.
Yeah.
But, well, is there anything else that you guys want to add or ask Dan? Or Dan, is there anything else you want to say about NatureWorks or Ingeo or PLA in general? Or
No, I would just encourage people to, we're putting out a preferred filament suppliers guide. 3DPS is one of the companies that we're highlighting. Certainly worked with some of the primary people involved for a while, and they know our material well and can produce a good product. And look to that filament suppliers guide and look for those that we highlight rather than just the general PLA, so that you're getting a good quality material. And if you have more questions, certainly these guys are a great resource here at Fargo 3D Printing, or go to our website as well, www.natureworksllc.com, for more information on our material.
cool. Well, thank you. I mean, it was great to have you today, and yeah.
Oh, that's right. I usually do the ending.
Wow. Oh, way to drop the ball, John.
Well, on behalf,
Bring in a guest and we get them all messed up.
on behalf of all of us,
And you're fired.
Yeah. So on behalf of all of us, myself, Jake, Dan Sawyer, and Todd Atchison, thanks again for watching. If you haven't already, subscribe to us on YouTube, subscribe to us on iTunes, follow us on all of our different social media channels. You name it, we're probably on there. So again, on behalf of all of us, thanks again for watching.
See you later.
Bye. It jumped up and started drawing chemistry. We could have done that if I could still do it. I could probably still draw lactite.